Lesson 41, functions. A function is just a mathematical rule that identifies a relationship between two sets of numbers. So it's kind of like if you had a machine. So they used to call it like a function machine or something. And let's say the rule was times it by 4. So we're just timesing by 4. And so we put a number in, that's called the input number. And then we times it by 4, and what we get is called the output number. So whenever we do, say, like an XY table, we think of the X as the input number and the Y as the output number. So let's say we put into our function machine right here the number 1. So we put in 1, we times it by 4, and we're going to get 4 for our output. If we put in 2, we times it by 4, we get 8. And if we put in 3, we're going to get 12. And then if we wanted to graph this on a coordinate plane, we would have 1, 2, 3, 2, 4, 6, 8. We're counting by 2's up here on the Y and by 1's on the X's. So at 1, Y was 4, at 2, Y was 8, and at 3, Y was 12. Wait, 2, 4, 6, 8, 10. Oh, that one's 12. So I drew that wrong. So at 3 we had 12, and if we were to draw, we would have a array right there. Or it would be a line if we kept going with negatives. So for every input value, and this is for functions, so for every input number, a function will have one and only one output number. So we can describe functions by words, by an equation, or even by a graph. So let's talk about, let's give an example here. Let's say we have a function machine, we put in a number and we get out a number. Let's see if this is a function. So if we were to graph this at 1, we get 10. At 1, we get 9. At 2, we get 7. At 2, we get -3. This is not a function because for the input value 1, we had 2 outputs, but by definition you're only allowed to have 1 and only 1. You can't have these 2. Or with the number 2 we input, we got 2 outputs, so it's just not going to work. This is not a function. Here's an example of a function. P equals 4s. This is like perimeter of a square. Take 4 times the side length. So for our input, we're going to put in our side length s. For our output, we'll get what the perimeter is. So if the side length is 1, the perimeter of that square would be 4. If it's 2, the perimeter would be 8. For a side length of 3, the perimeter would be 12. For a side length of 4, the perimeter would be 16. Now, in a square, we cannot have a negative side length, so we're only going to have quadrant 1 showing on our coordinate grid, or we're only going to be able to do quadrant 1. Trying to count by 4 twos, and I'm counting by 2, 4, 6. This is going to be 8, 10, 12, 14, 16, 18, 20, 22, 24. I only really need 16. Then the bottom, I'm going to count 1, 2, 3, 4. So if the side length is 0, the perimeter is going to be 0. So we're just going to have 0, 0 there. 1, 4, 2, 8, 3, 12, 4, 16. And this is going to be a straight ray. It's linear. It's a linear function because it's a straight line. So anytime you have a straight line, it's called a linear function. Can everyone just say linear function?
Linear function.
Okay, good job. A proportional function. Everyone say proportional function.
Proportional function.
Yeah, good job. Is basically it's linear and the points align with the origin. Remember, the origin is point 0, 0. You can tell that a function is proportional or linear if the ratio of output to input is constant. So if you look at our table up here, if I did the output, which was 4 divided by 1, I'm going to get 4. 8 divided by 2, I get 4. 12 divided by 3, I get 4. 16 divided by 4, I get 4. It's a constant. It's constantly 4. So this one, oh, and it goes through the origin 0, 0. So it has to have both those things. And then it would be considered a proportional function. Oh, there is one thing I wanted to talk about with when recognizing functions. It's called the vertical line test. So if I have a graph of a circle, remember we talked about in a function, you could only have one value for every x. So if x is 1, and you look at the circle, the output for 1 goes up here and down here. So this is not a function. We're just looking at this little vertical line here through 1, and it has 2 outputs. So it's not a function. Here's another one, anywhere where you draw the line. If you had, say, a parabola, you could think about a vertical line anywhere on this parabola, and it's only going to go through 1 point. So in that case, it is a function. So you can always look at a picture or a graph and use the vertical line test to tell if a graph is a relationship is a function. And that's the end of the lesson.